I'll take a simple system and go through the different ways and the different stages of commissioning. The first stage is to check the wiring. You could do a 100% point-to-point checking, where you check that each core is connected to the correct place using some sort of continuity check. To do this, you disconnect one end from the PLC and check continuity to the switch. Then you disconnect the other end from the PLC and check continuity to the other side of the switch. Personally, I think that's a colossal waste of time. A simpler way is to simply close the switch and check the correct input comes on. So you close the switch and a light should light up on the PLC, or you should see something come on in the software. You can either use the LEDs, they all have them. A better option is to load a quick test program, just inputs and outputs, into the PLC and check through the software. Analog inputs, such as the temperature, are best checked through the software. Firstly, you have a look at it and check that there is a value. Then you disconnect it at the sensor. If everything's okay, the wiring's okay, the value should go away. It'd go to 0 or negative or something. Then you reconnect it and the value should come back. You should do this well before calibration time because the sensor may need to warm up. With the outputs, the contact outputs, firstly you go and check that it's all right to switch stuff on, because there's a chance you'll be turning stuff on once you start clicking the outputs. Then you turn it on in the software. If everything's okay, click, the correct contactor should come on. Analog outputs are best checked through the software. All PLCs allow you to manually enter a value. It's called forcing. You force the output to 0. Then you go to the valve, or you have someone else at the valve, and he checks that the valve has gone to 0. Then you force the output to 50%, and you check the valve goes to 50%. Then you force it to 100, and you check it goes to 100. This way you've checked the range. Then you force it back to 50 and check the valve goes back to 50. It's essential that you do this because that proves that there isn't a bias, an incorrect voltage floating around in there, and that they are both working on the same 0-volt reference. Finally, you force it back to 0, you check the valve goes back to 0, and then you remove the force. It's very important to remove the force so that the thing is back on auto control. Now we transfer and test the software. You should already have tested the software in simulation mode, so now we just need to marry the software to the hardware. So you check the software assignments match the actual hardware. That means that where the software says input 1 is switch 1, that it's actually correctly wired up. We may also need to calibrate sensors. In this case, we'll calibrate the temperature sensor. So we get our test gauge, and our test gauge says 21.5. And in the software it says 22, so we need to calibrate that. There's probably an offset value that can be entered to make the PLC match the calibrated test instrument. And then once that's done, it's all good. 21.5, 21.5. Next stage is optimizing stuff. Perhaps we've got some control loops that need tuning. We might have some PID tuning to do. We deal with that in another course. Having commissioned the individual PLCs, the components, we now need to check the network and interconnections. There may be variables that need to be passed from one PLC to another. As you do your commissioning, you fill in the commissioning checklist. Remember that this is a legal document that may be used against you in a court of law.